Okay, good morning, folks. What we're going to do is a continuation of what we started yesterday. We started solving this problem here, um, which was on sale objects, and I modified this problem yesterday. So right now I'm not meeting all the requirements. I did meet all of these requirements yesterday, and then just for demonstration purposes, I changed my code just to kind of demonstrate what I built here were these auto implemented properties. And if you haven't watched yesterday's, or if you didn't pay attention yesterday about what an auto implemented property is, that's a must watch. Okay, you really need to understand these auto implemented properties because they are very, very common in C Sharp. Okay, the big spoiler on these, right? If you don't want to go back and watch the video, the big spoiler is that when you have these auto implemented properties, they automatically create the instance field for you. You do not have to wire up an instance field and set an instance field and get an instance field. It's just done automatically for you. Okay, and so just to kind of review the current state of what we did and just kind of how I'm going to go forward, I've got 3 auto implemented properties. And again, this is not meeting all the requirements.
Do you have to put the underscore sometimes with it, or you could just take capital?
The underscore is the instance field.
Okay.
So when you do these that don't have the underscore, you do not create that instance field. You do not create that variable with the underscore. This is shorthand for creating that underscore variable for you. Okay? Now, again, just kind of like it automatically creates that for you, so you don't create that. Then part 2 is these only work in certain conditions. And those conditions are when you can put anything into the variable and pull that variable out without any additional business rules. Okay, so if there's more complex rules about how tax owed is calculated, you might not be able to use this shorthand form, this auto implemented property. Okay, now, on the form, I just have a little prompt for a sale amount and inventory number. And up here, I've got a list of daily sales. Okay, and so this list is pretty much empty. And I want to demonstrate, again, here's my daily sales dot add new sale, and using this object initializer. Notice this is the constructor call, but I'm going to put some curly braces behind this, and I'm going to use these auto implemented properties to add an inventory number, a sale amount, and a tax owed. Again, if you really want to solve the problem like I did yesterday where the tax owed was calculated more specifically, you got to go back and watch that video. But let's just say inventory number equals sale amount equals, and I think this needs to be a decimal, so 100 into whole number 100 will automatically cast to a decimal, and tax owed is 8. So we can manually add the first sale object to our list, but instead of hard coding this, we can get the inventory number from a text box. txt inventory number dot text. Sale amount is convert to decimal text sale amount dot text. So now I'm setting the inventory number equal to whatever they put in the field, the sale amount equal to whatever they put in the text box, and I'm just going to hard code a tax owed of $8. Again, not meeting all the requirements, but I'll comment that out and comment that out. Okay, this is Okay, so we add a sale, we add that sale item to the list, and then we loop through the list. If I run this, just kind of get a sale amount's $1,000, 1A, 2B, and we need to sale item. Oh, I need to bring in my toString back. I deleted my toString method. So let's public override string toString, and let's put in a toString method. The inventory number, and now we use the property to get the inventory number, had a sale amount of sale amount and a tax of. So inside of the class, you call the get block of these properties inside of your methods, and this is calling the set block, right? So when you have an assignment operator, you're calling the set block. If you just have it without the assignment operator, you're calling the get block of the properties. So now that I've got my toString, I'm looping through my list of sales and printing out each toString of each item. And if I say 1,000, 1A, 2B, and if I say 2,000 and 3C, 4D, okay, we should put a line break in there, but it's printing out basically each one and clearing it each button click. And this is looping through and printing it. So let's put a line break in our toString. Now we're ready to go forward back into the second part. 1A, 2B, 2,000. Okay, now keeping in mind that our tax is no longer calculated like it was yesterday, I'm just hard coding the tax of 8. You can see I'm filling up a list. Now let's get into this requirement. Create a program that after 10 objects are displayed, they are sorted in order by the amount of tax owed and displayed again. So obviously I just can't have a hard-coded 8 because then all of the tax owed are the same. They're not going to really show you the sort. So what does it mean to sort objects? Well, when you have an object can be anything. Therefore, how do you sort that thing? Well, you have to define that. There is no default kind of way that you sort an object. You have to say, okay, this sale, we're going to sort it by the property of tax owed. So you have to define the sort, and that's what we're going to do. I'm going to add another field for tax amount right here. So we can allow that to be put in by the user instead of calculated like it was yesterday. Again, if you need that to be calculated, I did that in that last video. Text, tax amount. And now, instead of setting my tax owed equal to 8, I'm going to convert to decimal text tax amount dot text, and I can kind of make that look a little better, I think. There we go. So this is adding a new sale to my list using an object initializer, which uses those auto-implemented properties, pulling from the form. And now it should allow me to 1,000, $2,000, just code like it's double 16. Okay. Now it basically says, hey, after you input 10 items, do a sort. I'll just do a sort every time, so that every time I add a new item to the list, I'm just going to sort the whole list. When when you want to implement a sort, again, you have to define based on what property you want to sort on. Again, we want to sort on tax owed. This is done by what's called implementing an interface called iComparable. And you can kind of see there's two versions of this. There's one that takes this generic and one that doesn't. Like if I'm just looking here, there's iComparable with these angle brackets and one without. I'm going to do the one without. So the code to implement an interface is as such. You put a colon after the class and then iComparable. Now what does implementing an interface do? It forces your class to have a behavior, right? And what's a behavior? A behavior is a method. And so iComparable is an interface that's going to force our class is a sale class, to implement a method. And in that method, we're going to define how to sort sales. Okay? So when you do this right away, you can see the error says sale does not implement the interface compare to. And so you can kind of wire this up and it'll say implement an interface. So literally I just clicked on that, and what that does is it puts in kind of a method header for us that we can use to begin to compare two sales objects. Essentially, you have to compare one sale object against another. Now, this syntax, object O, this should be, and you can accept this as an object. So I'm going to kind of code this up based on memory. I might need to tweak it a little bit. But basically what we have to do is compare two sales objects by their tax owed. And you have to say basically one's greater than the other. And so when you're just comparing two objects, they both have different tax amounts. And one would be greater than the other. If not, they would be equal. And so the syntax for this, you're gonna notice this parameter is an object data type. This question mark means that it's nullable, which means that it could be a null object. Okay, so this is a nullable data type, which means it could be, OBJ could be null. So what we need to do is we need to take in that object. And there's a cast that can be done. Now this says OBJ as sale. This takes object and converts it to a sale. Now this is not the syntax that I normally use. You can do sale OBJ. And this is kind of giving you a little warning saying that OBJ could be null, and you can kind of suppress that warning by putting that exclamation point. That warning is not really going to bother me, so if I could just leave that there, no big deal. So basically you're passing a sale object in to this method. And so because I know it's going to be a sale object, I'm just going to convert it to a sale object. So this sale2 is going to be obviously a sale object. Then notice it returns an int. And so there's really three conditions. There's, greater than will return a 1, less than return a 0, but then there's equal to, which again, I'm just going to do this from memory. So there's greater than, so less than return, I think maybe -1 is how this works. Equal to return a 0. I'm trying to remember. So obviously greater than, we're going to return a 1 for our int. Less than, we'll return a -1. If the two objects are equal, we're going to return a 0. So those are the three return values. It's either 1, -1, or a 0. And those are the three integers. And then I'll show how this method really is called. So So this compared to method, we'll say if this dot tax owed is greater than sale to dot tax owed, int return val, we'll start it off at 0. So if the first tax owed is greater than the second tax owed, return val is 1. Else if their sale, well, if this tax owed is greater than, else if sale to tax owed is greater than this tax owed, return a -1. Else we don't, well, there is, we're already setting return val to 0, so it doesn't really make sense to, if they're equal, it's already 0. And then we just return val, semicolon. Okay, so we kind of have 3 outcomes, and that outcome is, well, one tax owed is greater than the other, or it's less than the other, or they're equal. And so based on those 3 potential outcomes, we're returning a positive number, a negative number, or a 0. Okay, so this is going to allow us to sort our objects by their taxes owed. Now, what you may remember from the array chapter was that there is a built-in array.sort method, right? How many people have used array.sort in their labs? Maybe somewhere along the way, a handful of you remember that, okay? Array.sort, when you pass it an array of objects, automatically calls this compare to method. So when I do an array.sort on a list, I was wondering, okay. It says cannot convert a generic list. I was wondering if it would take in a list. It looks like I have to implement that other version for this array.sort to work. I was wondering about this. Daily sales is not null here. Argument 1, cannot convert from a list of sales to an array. Yeah, an array, this ultimately, this is not an array, this is a list. So it's having a problem converting it from a list into an array. An array. So either I make this an array because it doesn't like my list, or I'm not sure if I do this and refactor my code to implement the generic version. Let me comment that out. And comment this out. Okay. Let me see if that makes it happy. No, I didn't think so. Okay, I'm going to undo this change. Control Z.
Is there anything like list.sort or something? Like something specific to this?
You know, that's a good question. Is there a list.sort instead of array.sort? That might...
Nah, I doubt it.
I know there's... other ways of doing this.
Mr. G,
Sir,
you can dot to array it maybe?
dot to array. That might make it happy. Thank you, sir. Good eye.
Yeah.
So let's try that. So we have a list, converting that list to an array. Let's see if this all plays nice. So this array.sort should call this compare to, and let me bring that back to this. It's not doing our sort. Well, let me refactor this quickly out of a list into an array. And again, there's other ways of doing a sort here, but instead of a list of sale, let's have an array of sale called daily sales. Daily sales sub count equals new sale. So that's going to be daily sales sub 0. Okay. So quickly refactored this into an array of daily sales with a count of 0. And then all I need to do every time we insert a new item, we're going to send count plus plus. Okay. So I'm going to put in a breakpoint and just kind of trace my code. So I'm going to hit start. 1000. Well, that's funny. Put my item in item number 9 because I sorted them and my sort worked. This is funny. Check this out. My sale amount, so my sort worked. My sort worked, and watch what happens to my sort. Got 1000. Inventory number 1A, 2B, tax amount 8. So right now, go ahead and create my first sale, increase my count. Now if I look, and you're getting a foreshadow on some troubleshooting tools, so this is really useful stuff. I've got a daily sales variable right here, and my first sale object at position 0 has an inventory number of blah, 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 blah. So my sale object is in my array. And after my sort, notice I'm sorting, therefore my last element, element number 9, now has my object in it because, well, null is going to sort before any other value. And so basically it's going to print out the first item, but there is no first item. The first item is empty, right? So I don't want to loop through you know, I don't want to loop through all of my items. I just want to print out the items. In other words, it's working. My sort's working. Everything's working the way I coded it. I just need to not print out items that don't exist. And that's what it's basically doing right now. It's printing out items that don't exist. And so I might, now that I'm thinking about it, you know, I'll do an updated one on how you do sorts on list of objects right now, because this is only working for arrays. But one at a time, it's, so instead of a for each loop, oh, how do I tie this in together? Here, let me bring this back. If item is not equal to null, there we go. So just check for a null value. If the item is not null, then print out its toString. And there's other ways of coding this. Okay, and let's just say 50. You notice the 50 goes on top, 1 goes on top, 3000 goes on bottom, right? So we are sorting our array, and when we're looping through all of our sale items, we're only printing it out if it's not null. The problem was in our list, or in our array of 10 objects, 9 of them were null. So it was hitting that first one, which was null, and it was crashing the program because you can't call the toString on a null item. So we check for null and then print it out. Okay, I'll do a little update on this, on how to do a sort on a list, but I just wanted to get this to work well, really per this, because this does say an array of 10 sale objects, right? So now I have my code factored into an array. Click a button, add a new object to the array, sort the array, print out if it's not null. Probably for my class, the biggest takeaway of what's in this code is this piece right here. This is called an interface. An interface is forcing a behavior on my class. The behavior is this method called compareTo. It made us write a method to basically say, how do we compare two sales objects? Well, we decided to compare it based on this property of tax owed, and then, you know, returning positive if one is greater than the other, returning negative if the other one's greater, and returning 0 if they're equal. So those are the 3 possible outcomes. But point is, we're kind of jumping ahead just a little bit to this concept of an interface, which I think is next chapter or 2. All right, and this is a working demo. Took a little longer than anticipated, 30 minutes. We'll stop the video here. Any questions, comments, concerns? Again, a little foreshadowing for what's to come.